Alright, welcome back to the Small Engine Mechanic channel. Today I'm going to be talking about and demonstrating this little Onan genset. It's actually a military PE-88 power unit. There was a little glimpse of this generator in a previous video. It was partially disassembled at that time. For a few small repairs and just a little assessment to see what would be needed to get it up and running. Here's a shot of the data plate on the unit. First, the military ID plate. I'm not very familiar with like the nomenclature of military units, but I don't know if this 44 here is the year of production. I'm going to guess that it is. So we're going to call this a 1944 power unit. 350 watts at 115 volts AC power. And then it's got a small DC output as well for battery charging. The Onan data plate is right below it. 3.1 amps at 60 hertz AC power, 8 amps at 12 volts DC output. So the front of the unit, it's got this nice operating instructions plate on it. Now, I mentioned it was partially disassembled for some repair. Let me slide it over here. Repairs included a weld to the front shroud here. You can see behind the fuel tank. It's barely noticeable. I was going to paint it, or try to match this paint and paint it to cover it up, but I don't even think it's necessary because you can barely see it. And another repair to the cylinder head, where this handle bolts to the cylinder head below this screw here. That little boss had been broken off. I think it was just rough handling. I bought this at a show, and you know, you can never tell how long somebody's been hauling something around to try to sell it. So, you know, there were a few screws missing. The front cover was loose and the handle was loose, so I'm guessing just got knocked around and snapped. But it's all solid now. So while it was apart, I just decarboned the head. Didn't do much else to it. I didn't check the valve adjustments yet. You'll hear in the video the valves are a little noisy, so perhaps I should have did that before reassembling it, but I wanted to see it run. Clean the little carburetor up. You can see it drips a little bit of fuel if it's been sitting. So gotta make myself a new gasket for the seam there. From what I've seen, these carburetors almost always snap off at the elbow here, and although it is kind of tucked away in the unit, close up, nice and tight, I have found myself in working on the unit, you know, moving it around on the bench and things like that, finding it very tempting to just grab on here just to slide it around or grab the carburetor, but having to catch myself before I snap it. So it just threads into the block with a cylinder here, the cylinder casting, and that's a 3/8 pipe thread with a jam nut and a little copper washer behind there. And it doesn't really have an air filter. It consists of this down tube, which has a screen soldered into it, like an angled screen. So that's the air filtration. One thing that some might notice that's not correct is the spark plug wire here, the ignition line. Now, this is the wire that it originally had. It had your typical shielded military style or aircraft style spark plug wire. It's a long one at that. It has to come from here all the way down to the flywheel magneto underneath. And the wire was actually broken. It had been soldered. This little end had been soldered onto it with a, looks like just a little copper lug. So it wasn't correct, and the shielding box for the spark plug was missing, so I don't have that. I don't have a spare. So for now, I just used a piece of solid core spark plug wire. And if I find the correct shielding cap for the spark plug, I think I'll remove the wire from this braided loom and reuse it, because the loom's not in bad shape. It's got a little kink right here, but it's not that bad. Put this out of here. And I took the back cover off of the generator, made sure all the brushes were free in their holders. Everything looks good there. Shot of the back. You got a start and a stop button, and a charge rate controller. It's labeled high and low there. Slide it over a little bit more. Sorry, my benches are always quite overrun with things. You get your battery negative and battery positive posts, and this here is a remote start connections. So you've got a ground here. This is terminal 1. Terminal 2 runs up to the ignition, so that's the kill wire for the ignition. And number 3 is the actual number 3 is B positive, or battery positive power. So that's power running from the battery positive through a coil, the starting contact coil, and when you ground that by closing it to number 1, you crank the engine over. Likewise, when you ground number 2, you kill the ignition, you stop the engine. So it's something I wanted to bring up here about this unit, which I don't quite understand why they would put remote start capability on the unit, a gasoline unit with no means of electric or automatic choke. So I just thought that was strange. Maybe you're meant to start it up, use it for a time, and then stop it remotely, and then restart it some short time later where you don't need choke. But in starting it, I found that choke is pretty much necessary. You can get it to putt a little bit, but you need a little bit of choke to get it to fire. So maybe that's me. Maybe I need to richen the mixture up a little bit so that it'll fire without choke remotely. But maybe with playing it around, we'll see if it'll start on its own without choke, that is. So, and then I'll move up to the receptacle box here. It's got 2 of your standard 15 amp receptacle here, 110 AC they call it, and then you have one here which I'm thinking that says RC115. This receptacle is interesting. It looks like it might be, well, it looks like offhand to be a 120 240 volt receptacle, where you have 2 lines of 120 volt, a neutral, and then a ground. This is interesting. This unit doesn't make 240 volts, it makes 120 only. And you've got a neutral and a hot, and then a ground, and then you've got this auxiliary conductor, which would be in the plug you plug it into. Now, that auxiliary conductor and a line off of the ground come down into almost a little contactor inside here, and when you insert a pin in this hole, this PL55, I'm not sure what that is, you close the connection between this insulated wire in the cord and ground. So I don't know if that might be some kind of shielding for if you're using this with a radio set and you don't want any interference. You can put your your pin in here for whatever cord you're using or whatever set you're using, and give it a little bit of noise interference protection. I'm not sure. I haven't found the technical manual for this unit yet, so when I do, maybe I'll come back and repost that information, make a follow-up video. And by the way, on the receptacle here, there's a hefty capacitor across the across line and neutral. I'm guessing just for noise filtering, and neutral is bonded to the frame on this unit. So, swing it around and talk about one more thing before we start it up. There's another set of points under this cover here with a condenser. They're not related at all to the ignition system, In fact, they've got there's a wire running from the insulated point back into the generator section. I've heard a couple of mentions of this around, and I believe they're called flicker points. I'm not exactly sure what their function is. I'm assuming they're, again, for some kind of noise suppression or maybe output waveform stabilization. I'm not really sure. So if anybody's got information on that or has had experience with that, you know, feel free to leave a comment and educate me a little bit. So let me take this thing off the bench, take it outside, and we'll start it up. Okay, we're back here. The rooster's crowing over there. I don't know why. So we got it set up. Got a 12-volt battery for start. That light over on the left there is a 300-watt floodlight. We'll plug that in once we get it up and running. We're going to be electric starting it from the rear panel there. I don't have the remote start hooked up. And we'll see how it runs. Yes, yes. Quite an easy start on the battery. Spins it over pretty quickly. Let me apply a little bit of load. Or, in this case, quite a bit of load, because it's only rated at 350 watts. You can definitely hear it pick up the load. I'm going to zoom in on the governor and go back and unplug the light, plug it back in. You can see the governor response. So you note that green lever right above that slotted head screw, kind of in the center of the screen there. That's the governor arm, connected to a little piece of linkage to the throttle butterfly. So watch the response as I drop the load and place it back on. Sounds pretty responsive. I'm going to get a little analog frequency gauge. Plug it in. I'll keep you zoomed in a little bit more. Plug that in, and we'll watch the frequency, the no load frequency, and the frequency droop when it's under load. I'm going to lower the no load speed a little bit because it seemed to hold speed pretty well in response to load. It's a little bit fast. I'm going to bring it down a little bit. Alright, let me zoom back in a little bit. Alright, let's try that. No load speed, right about 62 hertz. Put a 300 watt load on it. It dripped to about, sorry about that, it dripped to about 59 hertz and recovered right to about 61. So we got about 1 cycle per second drop from no load to, I don't know, what do you call that, 85-90% load. Not bad. Take a little walk around. It's a little shaky. It's sitting pretty flat. My concrete here is not the most level, so it's hard to find a good spot. Seems pretty happy. No misfires. See my fuel shut-off valve dripping a little fuel. I've tried to tighten that gland nut, but I think I need to take it apart and repack it. No other major leaks otherwise, though. Still running on load. You can hear the clickety clack of those valves. Not that bad. Remember, I want to know what these points do here. If anybody knows, let me know. Let me go get a voltmeter so we can see what the battery's charging at. We'll also take a look at voltage droop from no load to full load. Give me 1 second. I'll be back. Alright, let's take a look at our output voltages. That's low charge. Let me bump it up to high charge rate, see if the voltage goes up. Oh yeah. Shoots right up. Back to low charge. Next time I run this, I'll put an ammeter in line. Just see how much the battery is taking. So that's a good running voltage. Let's check the AC side. So we're still on the load of our light there. volts, dropping to about 109, 110. Let's see what the no load voltage is. 122 or so, 120. I hope you can see that. There's a voltage, oops, sorry about that. There's a voltage adjustment resistor in the end cover of the generator, but I think I'm going to leave it as is. No, I don't see any real reason to touch it. Remember, this unit doesn't have a voltage regulator per se for the output, the AC output, so you have to expect some droop. Alright, let me drop the load off and shut her down. Close the fuel valve. Alright, that's it for these two videos, or I said for this one video. Thanks for watching.